So this is the CAD model of the box that I created. And this is going to be CNC'd. So for 90-degree corners, I need to make this dog bone shape. And so all the corners can sit with the clearance, because without that, there would be a radius, and then that would interfere with the 90-degree corners of the stock. So that's a little design tip. And I like to check it all in assembly to make sure nothing collides and everything fits together nicely. This is the clear acrylic plate right here. And then once I have verified that everything fits in the assembly, for the cam, I'll actually create another assembly. This other assembly will allow me to orient all of my parts. And we are not going to rebuild this. So this allows me to machine out all my parts in the same operation, or relatively same operation. In this case, I actually switched up the jobs to do this piece on a smaller piece, and then this on a very large piece. And the cam is actually pretty simple. So this contour does the ledge for the acrylic plate, and wrong button. If we do a stock simulation, you can see it comes down. This allows me to secure the part while I'm cutting the outer edges, as I can put little fasteners in these corners to hold the part down as the outer edges are being machined. So I just separate those G-code files, run them, and then screw in where the material was removed, and then run these outer contours.
Just finished up cutting, and this just pulls right out.
Ooh.
There's just a little wafer thin
tab.
Whoa. And then this one, we put some screws in after we cut this pocket. And let's just take these out. Okay. The finished pieces. Pretty good.
Short wall.
And then the tall wall. All right, so this one is actually quite loose because we didn't have any screws to hold it fixed in place, but we just have little hairs holding on. A little thicker over there, but right there, that's a little thick, but
it's the ramp.
Yeah. So it's thin, doesn't exist, it gets thicker. And these ones use screws to hold themselves in place. So, and that's the front, and it's a little lip so we can put an acrylic sheet in. Right, so we start with our base plate, and then our tall side plate with a little switch, and that slots right in there pretty nicely. And then we have our short plate, slots right there. And then we have our front plate, an acrylic sheet will go in there for a nice little protective screen. That'll get glued on there and screwed. And then
just one of these.
Yeah, a plate like that. We'll cut this out with a little hole for another switch. And then this is the back plate, which will go right there. And this will get mounted underneath a ramp for some Pinewood Derby cars to race down.
I think we need to place it with this. And have to go a long ways.
Inside is just an Arduino Nano clone, which is a little bit overkill for this application, but you know, the clones are very cheap and I had a couple of them lying around. And right now, just for testing, I use some potentiometers to start and stop the sensors for the Pinewood Derby cars. In the final product, they're going to be using photoresistors, so as the Pinewood Derby car rolls over the photoresistor, the brightness value changes, and the Arduino is able to pick that up and start the timer using that. But just for testing on the workbench, I used little potentiometers. And this whole frame is cut out of 12mm plywood. On the side, I have a little on-off switch. In the front, this is a reset switch and a little LCD. If I turn this around, there's a little LED strip that lights up the interior of the box nicely. And this box is held together with just some wood screws and a little bit of wood glue. So let's turn it on and see what I've coated on here. See, it illuminates very nicely. So right now it says racetrack ready. So this is when you place your Pinewood Derby car on top of the ramp and let it go. And then when you let it go, your car will go over the first photoresistor, and I'm going to turn this until it triggers. Right there, race started. That means the student's car hit the first photoresistor and the brightness value changed. Race started, timing, and then when they get to the bottom of the ramp, they're going to trigger the second photoresistor, which in my case is a potentiometer, and it collects their speed. And this speed is actually scaled up 25%, because that's a pretty common standard for Pinewood Derby cars. And their scale speed, I put the reset switch ready to race. So it will not enable until the car is off of the photoresistor timing switches. It says ready to race. And here's our sequence. Triggered. and then finished. Right there. 10 miles an hour. Not too bad, but if you kind of simulate the real delays, you can get a pretty decent scale speed for these Pinewood Derby cars. So triggered. There you go, 40 miles per hour. And then collect data, reset. And it's all with this on-off switch.